take a moment to pause this video to read the full problem statement. The main thing I want to focus on here is really Part B. I'll get into a little bit of Part C as well, and what the thought process is that you could use to decide what type of either formula or technology you can use to find this confidence interval. So first of all, this is a confidence interval that we're being asked for, specifically here in Part B, just kind of skipping ahead to that. And we're looking for a confidence interval for the mean. Actually, it's the population mean of these adult Americans. But I want to walk you through what we do next with that information. And my math lab has some really good resources here called mind maps. So if you go to Tools for Success, underneath Resources, you'll find Mind Maps. I'm going to scroll down to Chapter 9. That's the one that we're in. You can look at the PDF. You can watch this video summary that kind of walks you through the PDF. But I'm just going to jump to the PDF itself and zoom in just a little bit more here. And the way I see this is in Chapter 9, what we're really finding is confidence intervals. That's what this is all about. And a confidence interval is a way to estimate the value of a parameter. The parameter is either the population proportion or the population mean. Those are the two types of parameters that we have studied anyway here in Chapter 9, and we're building these confidence intervals to make these estimates. Now, underneath that kind of umbrella of confidence intervals, you can see, well, for population proportion, you have to use either this formula, you have to check these conditions, or if you're in, let's say, StatCrunch, you're going to use Z-Stats, and I'm going to show you where you can find that. The other option is you're making an estimate for the population mean, so you're going to build your confidence interval around that population mean. You can either use this formula, you can check for these conditions, or if you're using technology, specifically StatCrunch, then you're going to use T-Stats. Okay, so returning to our problem here, we're asked to construct and interpret a 95% confidence interval for the mean. So if you print out that mind map, you can, or organize it your own way. But either way, when you think confidence interval for the population mean, I want you to think about T. Okay, T-Stats, the T-table, because you're going to end up using that student T-distribution table. If you end up doing this by formula or by hand, of course, you know me, I'm going to rather you do this with technology. So I want to show you where you can find the T-Stats in StatCrunch. So let's come over here to StatCrunch. I've just opened up this separate window. We're going to go to Stats. And underneath Stats, you do have a couple of options, Z-Stats and T-Stats. Again, when you see Z-Stats, think, oh, I'm creating a confidence interval for the population proportion. T-Stats, I'm creating a population or confidence interval for the population mean. This one was a population mean, so this is the one I'm going to use. From there, the only one that we're going to look at in our course anyway is the one with one sample. Okay, so that's the only one you'll choose. And in this case, we have a summary. We were given the mean, standard deviation, and sample size. So we're going to do with summary. So let's type in that information for sample mean, sample standard deviation, and sample size from the problem that we were presented. Now you do see some other things about what you can perform. So maybe later you're going to look at this one, but for right now we know that we're doing confidence intervals. We are estimating or finding this estimate around this population mean. So let's select confidence interval from U, that's the population mean. You type in the confidence interval that you want. In our case, it was 95% confidence interval, and then compute. What this gives you is your lower limit and your upper limit. The information that you need back here in this problem. So we can now say with an interpretation that one can be 95% confident the mean age for adult Americans, what they would like to live, is between 82.58 and 93.22 years. And we get that information, excuse me, these values here very quickly using StatCrunch. Now, yes, you can still use the formulas, but again, as you've seen throughout this course, there are so many formulas, and I would rather you spend time thinking thoughtfully here about what does this mean? How can I interpret this? Than bogging down here or spinning your wheels or your energy here. So let that technology help you out with that. For the last part of this problem, you're asked to find the sample size that's required to get this estimate that's within 2 years with 95% confidence. So I'm going to go back to that mind map, because beneath those formulas and requirements or conditions that need to be met, there are additional formulas that we may use to calculate sample size. Because we're dealing with population mean, we stick here underneath this particular branch, which means we're going to use this particular formula. So let me bring up my calculator for that. Okay, so I've got my calculator. I'm going to go ahead and start with the open parentheses and the fraction. The first thing I see is I need this z value. That actually comes from a chart in the previous section. And so I'm using really there the Z table or the critical values in that section 9.1, I believe it was. There was a table. You've seen it so many times, you probably have it memorized. It's 1.96 for a 95% confidence interval. And we're going to multiply by the given sample standard deviation, divide by the margin of error, which in our case was 2 years. Close the parentheses, square that, and this is what we get. Round up, I believe, is what the problem statement said, and so that's how we arrive at 231 is the required sample size.